Hi YouTube, today I'm going to talk you through how to carry out a basic bike check, checking for cracks and damage caused by wear and tear or road impacts. The reason I'm making this video is basically I've just checked mine out last week. I tried to do it periodically, every couple of thousand miles or so. I was giving the bike a clean, so decided to pull the fork out and check it, and actually found damage to it, hence why I've got a black one in there now. It's just a second hand job for the time being, till I manage to pull it apart and give it a lick of paint so it matches. So basically I'm going to talk you through how you go about checking for damage, and I'll show you the original fork and the damage I found on it so you know what you're looking for. Okay, this is the original fork out of the bike. It is basically an aluminium steerer, aluminium crown, carbon fibre blade, aluminium dropout. That's the damage to it, or rather the damage is on where the carbon fibre blade meets the crown, but we'll talk about that in a minute. I'll just show you how you go about checking this for damage. Basically, why would you be doing this? Why would you be removing your fork to check for damage? Well, basically, if you've had a hard impact, you've been riding in the rain and you've smashed an unseen pothole, or you've smashed an unseen pothole because you had to swerve out the way of a car, etc., come off a curb, or indeed you've crashed a bike and had a hard front end impact, you may want to pull the fork just to put your mind at rest and have a quick look. If you don't feel competent stripping the fork down, disassembling it out the bike, you can have a professional do it. Wouldn't cost too much, I don't think. However, if you've got the tools and the skills, it's a 10-minute job to remove, and it can save you a lot of heartache, save you a lot of pondering as well, and it's going to give you an answer straight away whether that pothole's actually damaged your fork or indeed your bike. Okay, I'll talk you through how you check it. Obviously, the top of the steerer, not expecting to find much damage there. However, in a heavy impact, it's possible you could flex or bend it, I suppose. But just give it a once over. Have a look for any heavy gouging or indeed any bending of the steerer or any cracks. This is one area to pay particular attention to on this model. It's where the carbon crown is bonded to the steerer, and as you can see, this line of glue here or adhesive, just have a good check of that. Make sure it's uniform all the way around and there's no chipping of the glue or cracking, evidence where the two parts have tried to move relative to each other. If there was, I'd imagine you'd have a gap either at the back or at the front, as is the direction of movement where they've tried to rip each other apart. This one's good, but just check for any cracks or signs of distress with that. Carry on down, give your crown race area a once over. Depending on how much of it you can see, just have a little look around the base here for any damage. As you can see here, this has scraped all the paint off where it's been contacting the frame. I assume it's been doing that during heavy braking, or where it's been flexing and just coming back and just touching the frame ever so slightly. This fork's actually been in the bike for 16,000 miles, so plenty of time for that. Then we'll move on to the crown. Pay particular attention to where the aluminium crown meets the carbon fibre blades, which is roughly this area, approximately this area on this type of fork. If you've got a monocoque full carbon piece, obviously that won't apply, but again, just you're gonna want to look over the whole thing to make sure there's no cracks or damage to it. Carry on down the fork legs, the carbon fibre blades on this model, and you'll want to look down both legs and follow all the way around, just checking for any distress in the paint, any evidence of movement of the carbon underneath. So you're looking for cracks. Distress of the paint could manifest itself as a whitish area or a lighter area than the paint around it, telling you that the paint's actually been stretched because the fork's been over flexed or whatever. Carry on all the way down to the dropout. Pay particular attention to your dropouts. On this model, it's an aluminium dropout bonded to the bottom of the carbon leg. However, it is possible to pick up, I'll try and get this focused for you, it is possible to pick up cracks with the actual within the actual dropout itself. So check both sides of the dropout on both legs. You're looking for cracks and deformation of that. Make sure all the gaps, the actual dropouts, are uniform themselves and there's no serious gouging or scoring of them. And I'll show you what damage looks like when you do find it, at least in the case of fatigue cracks. Right, I'll try and get the camera focused here. A bit of a mare at the moment. There we go. See on the right hand fork leg, you can see that little black hairline crack making its way from halfway down the fork blade all the way around here. Just turn it slowly so it doesn't lose the lock. And just terminating about there. And basically I didn't expect to find this, was a bit surprised when I did find it. And it was on both legs. That's a better view of it there for you. And you can see it's actually cracked the paint. And what concerned me was it was in the region where the carbon fork blade meets the crown. And it was on both legs, so it pretty much condemned the fork for me. It pretty much knew what was going on. But I've rubbed the paint off here, as you can see, with a bit of 80 grit sandpaper. Now that's a pretty extreme step. I was pretty sure it was damaged. I wouldn't advise you do this for any little blemish you find, unless you're 100% sure and just want to confirm, which is what I was trying to do. And as you can see, the crack is at the same height. As you can see on the right hand leg there, it's at the same height as the join between the carbon and the aluminium. So I was pretty sure what was happening was it was starting to delaminate, and movement was happening between the fork leg and the crown. Now, upon closer inspection, after I've actually removed the paint, there doesn't appear to be a gap there, or rather the gap's that small that I can't see it. So I assume maybe under heavy bumps it is actually opening up slightly and then closing again, which has caused the paint to crack and stay cracked. But obviously at rest it appears to be totally together. Now the way this is constructed is a carbon fibre blade here. It'll have a couple of pegs on it that'll push into holes actually in the crown, and it'll be filled with bonding agent or glue, and that'll be bonded together. Then the whole area will be filled and sanded and then painted to give it this one piece finish. And that is a particularly high stress area where those two meet. Like I say, it's been on the bike for 16,000 miles, so it's done quite well. But it's a good job I picked this up. It could have been quite a nasty accident if it had failed. Okay, we'll move on to the rest of the bike then. While I'm on the subject of carbon fibre damage, there is a check you can carry out if you are suspicious, or you've had an impact to a carbon part. Obviously it doesn't apply just to forks, but basically it's the tap test. You get yourself an old teaspoon and just tap along the length of the carbon fibre component. Now obviously it's the same model as the one I've just showed you. We've got aluminium at the top and aluminium at the bottom, carbon in the middle. So I'll shut up now and I'll just carry out the tap test, and you can hear the difference as I travel up the fork. You can hear it's more metallic at the top and the bottom, and hollower in the middle. Now obviously that's because I'm tapping on a hollow carbon shib. Now if there was damage under this paint, what I'd expect to hear is you go hollow, 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 and when you hit the damage it'd just be a dead note. So kind of like hitting a bit of bark on a tree, just like a dead dud noise. And that would indicate a problem with the carbon underneath. If you were to find that and there's no explanation for it, i.e. you're supposedly on a nice straight carbon part, then I'd stop riding it immediately and I'd get it straight to your shop to have it checked out properly to confirm whether there is actually an issue with that. How are you going to go about checking your frame over for fatigue damage? I would start with the handlebars and stem. Handlebars are a little tricky as they're mostly all covered up, but check what you can see, where you can see, especially in the high stress areas, sorry. So around the stem mounts here. Carbon bars are more susceptible to failure due to impacts and crashes, etc. But just doesn't hurt to give it a once over if it's aluminium or steel too. Stem faceplates are a favourite for fatigue damage and cracks, so have a good look around where it mounts on each of the corners here, here, here and here. This is a slightly strange stem given the bolts bolt in from the back. Most models will bolt in from the front, so have a little look around the bolt heads. Make sure there's no distortion or cracking from them. You want to make sure the air gap between the actual stem and the faceplate is equal, both sides, i.e. top and bottom. What that's going to do is, if it's equal, the stress on the bolts will all be equal, and it will actually prevent any stress, fatigue, fractures propagating in the first place. Carry on all the way down the stem, checking, paying particular attention to where stress areas are, where it's actually fixed to the steerer, the bolt heads. That goes for the rest of the bike as well. Anyway you've got a structural bolt, just have a good check around it, because that's where you're getting a lot of pulling forces exerted on the components. Moving on from there, you've got your top tube. Where your top tube is mounted to the head tube is a favourite area. Also on the down tube to the head tube. Check the welds, if it is indeed aluminium or steel. Check your welds, follow them all the way around, checking for cracks or again that evidence of movement. Move on down to the down tube and do the same thing. Follow them down to the next favourite area, which is the bottom bracket area. A little difficult to see here, but basically you can get cracks here because it's a high stress area. When you're out the saddle hammering away on the pedals, you're flexing this area all the time, so it's easy to pick up fatigue cracks here. So check that weld all the way around. It's easier if you've got the bike in a bike stand up at working height. Follow the seat tube up. Another favourite area is here because of the forces exerted by the seat tube. As you can imagine, when you're hitting bumps, the seat tube's actually flexing all the time, so you get a lot of fatigue cycles here. Just check run your eyes all the way around these welds, make sure there's nothing untoward going on. Check the seat post, whether you've got a aluminium or a carbon model. Check around the seat clamp here, again you've got a lot of stress, especially if it's carbon, because it can be over tight and it can cause issues there. All the way up the seat post to where the saddle's mounted, the saddle rails are mounted. Just worth having a quick once over there, make sure all that's good. Down your seat stays, on your chain stays, again following the welds, following all your high stress areas. Just as on your front fork, have a good look around your dropouts both sides, just in case there's any fraction or fatigue there. It's rare, I'm not saying it doesn't happen, but it's rare to find fatigue in the middle of a tube, because these are typically, your stress areas are typically the end of the tubes where the joins are. That'll be why you've got companies like Specialized with the smart weld technology trying to move the weld away from the high stress areas, just to make a more resilient frame and also to improve stiffness to weight ratio. You can also check out your cranks. I've seen cranks snap due to fatigue that wasn't picked up. Pretty much from the pedal end all the way down to the bottom bracket end. Just have a quick once over. Just make sure everything's good there, there's no crack in the material, etc, etc. Same story basically for all your different parts. Wheels, high stress areas are where the spoke nipples meet the rim. I've seen them propagate cracks here, and obviously what can happen in extreme cases is that will actually pull out while you're riding, which is not going to be good. And again, the tops of the spokes where it hits the hub, both front and rear, have a good look there, make sure all that looks normal. And that's basically how you go about checking a bike over for fatigue damage. If you were to find something you weren't sure about, I recommend you get it straight to a shop or a professional so they can give you an opinion on it, make sure it is safe to ride. Basically that's it. If you've got any questions, leave them in the comments. I'll read every comment and I'll try and answer them as quickly as possible. And if this has been helpful, please leave a like. Thanks for watching.